Okay, so I'm going to go into documents. Not documents. I'm going to go into Scratchpad. Oh, I've already got it there. I'm going to be a little lazy. Delete my points. So everybody's typing that and getting that function graphed. Okay, so it asks us to find three things. It asks us to find the zeros, the max, and the min. All right, how many zeros are on this graph? How many times does it cross the x-axis? 3. So I remember how we practiced that the other day. We did a whole lesson on the calculator, right? So I have to hit what buttons to get the zeros? Menu, then what? Analyze graph, then what? 0. And I don't care which one you do first. Pick one. I'm going to go to the left of it. I'm going to go till I see the word 0. All right, and then I have to do it again. Menu, analyze graph, 0, get the one in the middle. Okay. And then I'm going to do menu, analyze graph, get the last one. I don't think it'll let you get all three at once. I think only one comes up. Am I wrong about that? Let me try it. Nope. Menu, analyze graph. Only one, I think, comes up when you try to go. Yeah, it only lets you have one of them, doesn't it? Yeah, so. All right, then we have to get the max or the min. I'm going to go for the max first, that relative max that's right up here. So menu, analyze graph, and I'm going to choose maximum. Go to the left of it, go to the right of it till it says the word maximum and stops. The word maximum stops moving. And then I'm going to do the min same way. Menu, analyze graph, minimum. Surround the minimum there till it stops moving. All right, so we need to write those down. So the work you're going to show me on this problem is you would sketch the graph, okay? And then you would show me, and then you would write down all your zeros, your max, and your min. And you're going to write down the points. Go 3 decimal places, okay? So I'm going to sketch my graph too and put it in there and write what I would want you to write. It's my favorite thing to do is sketch graphs where I can copy and paste them. Okay. So our zeros, I would write down negative 1.4000, right? Negative 0.2630, and 1.7500. That would be 3 decimal places, right? Do I necessarily have to have those extra zeros on there? No, but I'm being official, I guess, today. Your max point was negative 1.2, and your min point was negative 1, no, not negative, positive 1.214 if I rounded it, negative 6.482. All right, give you about 20-30 seconds to get caught up with that, and then we're going to move on. Okay, let's look at the next box there. So go ahead and fill in the blanks in that box. Okay, eventually what we're going to do here in another example or two is we're going to sketch graphs. Okay, and this is going to help us with the sketching graphs. So for a polynomial function, a factor like this x a to the k where you've got a number there, gets us a repeated 0. And we started talking about that yesterday, of multiplicity, whatever that number is. Okay? If it's an odd number, the graph crosses through the axis. So if I had something like x minus 1 cubed, that means that it would cross through through that 0 if it's odd. If it was even, I had x minus 1 squared. When it's squared or even, it bounces off the graph. Okay, so that's the big difference between the two. All right, so what we're going to do in example 12 is we're going to reverse the process we've been doing. Typically, I've given you a problem, we've set it equal to 0, we've factored it, we've done the zero product property, and we've solved it. We're going to start with the solution, go to zero product property, and then go back to the original problem. Okay? So we got to think about it backwards. So I'm going to start by setting x equal to all of those. And yes, we're going to use the repeated. Okay? All right, so I have to think about getting them equal to 0 so that I can reverse zero product property. So division, how do I get that back to the other side? Multiply. So 2x equals -1. If I'm going to get that equal to 0, how do I move the 1? Add it. So 2x plus 1 equals 0. So our goal is to get each one of those equal to 0. What are we going to do with both of the 3's? Subtract them. So x minus 3 equals 0 and x minus 3 equals 0. I really don't need the equals 0 part at this point. Okay? But what I'm going to do next is I'm going to take all 3 of these factors and multiply them back together. I'm going to start writing it back into function notation. So I'm going to say f of x equals 2x plus 1 times x minus 3 times x minus 3. All right, what do we need to do? Well, it doesn't matter. I could pick any pair and FOIL them together. I could pick the front pair, I could pick the back pair, I could pick the 2 pairs on the ends. Doesn't matter. I'm going to choose the back pair, okay? So I'm going to start with 2x plus 1. I'm going to leave alone for a minute. And I'm going to get this FOILed. So what's x times x? Good. X times -3. How many of those do I have? 2. So what do I get in the middle? Good. -3 times -3 is? 9. Not going to FOIL anymore, right? We're going to get out the box to multiply these together. So we've got 2x plus 1 down that side and x squared minus 6x plus 9 up there. All right, let's use this like it's a multiplication table. So 2x times x squared is what? Good. 2x times -6x is? Good. 2x times 9 is?
Why wouldn't that -12x be squared?
Yes, it would be. Thank you. 2x times 9? 18x. X squared times 1? -6x times 1? And 9 times 1? 9. Now we're going to combine our like terms, okay? And then that's our final answer. So we get the 2x cubed. Our diagonals tend to be our like terms. So what's x squared and -12x squared? Good. -6x and 18x. 12x and then plus 9. I'd probably rewrite my function notation on the front to make it look pretty. So again, we start with it x equals, we reverse the zero product property, we get back to the original function. Okay? So look at the next one. I'm not going to do the next one. The next one you're going to watch on video, but you're going to want to watch it because what's weird about it? There's square roots in it. Okay? So that's going to act a little bit differently with the square roots. Okay? All right, let's skip to 14. 14, there's a typo in it. Okay? You need to add in that there's another 0 that's 0 and it's multiplicity 2. And let's take the degree down to 3 instead of 5. 5 is a little insane. Okay. Okay, so I'm going to do the same thing I did last time, only they set it up a little bit differently. Instead of them saying x equals 3 and x equals 3 in the last one, they just told us that there's 2 of them with the multiplicity. Okay? So I know one of my zeros is x equals -5. I know I have how many x equals zeros? 2. So I do x equals 0 and x equals 0. Our goal is to reverse zero product property, so I need each one of these things equal to 0. I've got 2 of them already. What am I going to do to move the 5? Add it. So we've got x plus 5 equals 0. All right. What do we need to now do with all these factors? We're going to multiply them together. That's right. F of x equals x plus 5 times x times x. All right. I'd probably do x times x. What's x times x? X squared. And then what are we going to do with that x squared? Good. So x times x squared is? Good. 5 times x squared is? Good. Did I get a degree 3 like they wanted me to have? Yeah, so that's a good answer. So it's basically the same thing we did. They just set it up differently, right? They gave you the instructions differently. All right. Just so you know, let's put this in there right now. Add that in because those were a typo in the notes too. So make sure that there's 0 is 2 and multiplicity 2 on example 15 as well. Okay? So fix that. We're not going to do the problem, but you can fix it before you get to it in the notes. Okay. Let's talk about 16. So 16 we're sketching. Okay? We've got to do a third degree polynomial, 2 real zeros, a positive leading coefficient. Okay. So there is more than one correct answer to this. Is third degree even or odd? Odd. So do my arrows point the same direction or opposite directions? Opposite. And this is how I like to think about it. When it has a positive leading coefficient, it's like a positive sloped line. So I know that this one has to point down and that one has to point up. If that doesn't work for you, go and compare it to the chart we had on page 63 of your notes. Okay? It says I have to have 2 real zeros, meaning I am crossing this axis twice. So I need to figure out, I'm going to maybe bounce there and go through it there. Okay. Maybe it looks like this. Maybe it goes through it here and bounces here. Do both of those satisfy the conditions they gave me? They're both third degree. They both are 2 real zeros. They both have a positive leading coefficient. Okay. Typically the number of humps that it has is 1 less than the degree too. That's another way to kind of tell. Okay, so third degree, 2 humps is 1 less than the degree. Okay? All right, we're going to skip 17, we're going to skip 18 and do 19. Okay? So we're sketching, but in these problems, we're going to do a slightly more detailed sketch. Okay? We're going to do the leading coefficient test to see which direction our arrows have to point. We have to find zeros, and then we're going to try to plot some points in between to see how low it might go, or how high it might go. And then we've got to draw a continuous curve through the points. So I'm going to start by giving myself at least a place to kind of start sketching things. With my leading coefficient test, do I have an odd or an even degree? Odd degree, so does it point the same way or opposite ways? Opposite ways, and is it positive or negative? Positive. So it's got to look like a positive sloped line, so it's going to do something like that. I can at least draw that on there, I know that much. All right, to get zeros, we set it equal to 0, and I factor. What's my greatest common factor? I'd probably go 2x squared. It would work if you just pulled out the x squared, but 2x squared is probably better. What are we going to be left behind with? X minus 3. What property do we need to use? Zero product property. All right, we're going to do what with this 2? Divide by it, so we'd end up with x squared equals 0. How do we undo the squared? And what's our multiplicity on that? Our multiplicity is 2. That means at x equals 0, it's going to do a bouncing thing. Okay, I don't know if it's going to bounce this way or bounce this way yet, though, so I can't draw it in. Okay. All right, what am I going to do with that 3? Add it. So I also know I have a 0 at x equals 3. But here's the thing. Do I know what's going on in between here?
No.
If I had a better idea of what was going on in between there, I might be able to draw a better sketch. So I'm going to pick on those numbers that are in between there, and I'm going to do a good old t-chart. When all else fails, we can always do a t-chart, right? And plot a bunch of points. So what are these two x values that we skipped over? 1 and 2. So, and again, I just picked those off the graph because they were between kind of my two zeros. All right. I'm going to now plug those values into this function. So when I put in a 1, what's 1 cubed?
1.
Times 2 is?
2.
Notice I put a little scratch work there, right? 1 squared is?
4.
Times negative 6 is? So 2 minus 6. So I know I have a point at 1, negative 4. All right. Then let's put in the 2. So 2 cubed is? 8 times 2 is? 16. 2 squared. 4 times negative 6 is? Good. So 16 minus 24 is?
8.
Negative 8. All right, so I'm going to go out 2, down 8. So are we kind of getting a better picture of our graph? Do you have to do every single point that we have on there to get a picture? No. You're just going to do the ones in between your zeros. Okay, so if there were 3 zeros, I'd probably pick on at least 1 in between each 0. Okay, I know it's got to start down. We already said it was going to bounce off there. I'm going to bring it down. It might go lower than that because I don't know what's going on at the halves, right? Or the quarters or any of that. But at least that's a good relative sketch of what our graph would look like. Okay? All right. I'll let you finish sketching. So here's what we're going to do next. Any homework that you have that I still need to stamp, you got to get that out. If there are partial weeks, I need to see those. Okay, so I'm going to probably come by and I'm going to verify your stamps and make sure that we have everything done. Okay. While I'm doing that, you're going to put on your headphones. You're going to go to Haiku. And underneath the homework assignment for tonight is a video of the examples we didn't do in class. You're responsible for getting those watched. You have time right now. Okay? And write those examples in your notes. Okay? You need to get those complete in your notes. All right? Any questions on what you're doing? All right. I'm going to come and stamp right now. Okay? If you're thinking you're going to try to get stamps later in the day, just know I leave at the end of 5th period. I will not be here after that. Okay? Yeah. I'm here at lunch. Okay? So, but after 5th period, I am not here. I am gone. All right? I have to come back for the football game, so I'd like to spend a little bit of time with my own children tonight. Okay? All right. So, I'm going to stop this. I'll be around in just